welcome back to the channel. So today in this video lecture we'll be solving this problem, find peak element, which is a problem which can be solved using binary search concept. So in this problem we're given an array, that is an array of n integers. It is a zero indexed array. It is named nums. We have to find the peak element in this array and we have to return the index of the peak element. So what is the peak element? Basically a peak element is an element in the array which is strictly greater than both of its neighbors. Okay, that is a peak element. Now there can be multiple peak elements in the given array. We can return any of them. Now we can imagine that the number just before the first element of the array and the number just after the last element of the array is minus infinity or very small. In other words, an element is always considered to be strictly greater than a neighbor that is outside the array. That means there can be the cases where the corner elements, i.e. the first or the last element, can be the neighbor elements, and in that case can be the peak elements, and in those cases we just have to check if those elements are greater than their only neighbor. That is, the first element is greater than the second element and the last element is greater than the second last element. We must write the algorithm that runs in O log n time. That means we must use binary search to solve this problem. So let's better understand the problem statement using an example. So here we have an example. This is an array of 7 integers, and in this array we can see that this is the peak element, that is 6, because 6 is greater than 5 and it is greater than 4 as well, and the index of this 6 is 5. So the answer for this array will be 5. So how can I solve this problem? It is easy. We just have to use binary search. So let's use two pointers L, initialize it to the very first number, and the second pointer R, initialize it to the to the last element of the array. So the initial range would be 0 to 6. Fine. Now find the middle element, that would be L plus so we calculate the middle element like this. So L is 0, 0 plus 6 minus 0 by 2 would be 3. So we go to the element at position number 3. So 0, 1, 2, 3. This is the element which is there at the position number 3. Now this is the middle element. Let's call it M. Now I can see that this is not the peak element because 3 is not strictly greater than both of its neighbors. It is greater than the left neighbor, but it is not greater than this 5. So we have, that means, how would I check that? Now since this is not the peak element because it is less than the right neighbor, that is this one, so the range will change to M plus 1 to R. So this will be splitted to 4 to 6. Why? Because since this 5, the right neighbor, is greater than 3, I will find my peak element in the right half of the array. So L is initialized to this number and this space is discarded. Now again find the middle element. For this new range, the middle element would be this, that is 6, and this is indeed the peak element because it is greater than both of its neighbors. It is greater than 5 as well as 4. Fine. So we return the index of this middle element, that is 5. So the answer is 5. That's how we calculate the answer. In case, let's say I would have like something like, let's say 5 would have been here and 1 would have been here. In that case I would have discarded the right space. Why? Because I will find my peak element in the left half of the array because this is greater than the middle element. Fine. So in this fashion we have our binary search conditions. So let's discuss the edge cases. The edge cases would be in case we have only one element in the array. Let's say this type of array. In this case, this is the only element and it is the peak element as well. So we return the index 0 here. Consider the cases where we don't find any peak element in the array where we have, consider the cases where we have the first element, let's say 5, and the second element to be 2. This is one of the cases. Now I can see that I assume that the element at this position, that is at -1th index, is -infinity. It is very small. That means the first element is always greater than the previous element. Now here we can see that 5 is also greater than 2, 5 is also greater than -infinity. So this is my peak element. This is the second edge case. Let's handle the third case. Let's say we have like this 5, 2. We have our array. Now here at this position we again have -infinity. Now here 5 is greater than both of its neighbors, greater than 2, greater than -infinity. So this will be my peak element. Fine. So that's all we have to do in this problem. Let's jump into the code implementation part. So this is my solution class in which we have find peak element function. Let's calculate the size of this array. That would be nums dot size. Initialize 2 pointers, L to 0 and height R to n minus 1. Now check for the base conditions. If n is 1, if we have only element in the array, return 0. Now check if the first element, that is nums of L, is greater than nums of L plus 1. In this case, return 0. Otherwise, check if the nums of R is greater than nums of R minus 1. In this case, return n minus 1. Otherwise, decrease the range. L will be incremented by 1, R will be decremented by 1. Run the usual binary search, L less than equals to R. Find the middle element, that would be L plus R minus L by 2. Check if the middle element is the peak element. If it is the case, then it is greater than the left element or the right element. So mid plus 1 and nums mid is greater than nums mid minus 1. Okay. And if it is the case, then that means this is the peak element. So in this case, return the mid. Fine. Otherwise, check if nums of mid is greater than, if nums of mid is less than nums of mid plus 1. If it is the case, then that means the peak element lies in the right half of the array. So L will be reinitialized to mid plus 1. Otherwise, R will be reinitialized to mid minus 1. Fine. If I don't find my middle element, if I do not find my peak element, then return minus 1. So let's try to run this code. Okay, it worked for the sample cases. Let's try to submit it. Okay, so it got accepted. So it was a pretty simple problem, find peak element, one of the standard problems of binary search. So I hope you enjoyed this video, and if you like the video, hit the like button and make sure to subscribe to the channel, and continue in the binary search series. We'll be adding more patterns